doubles every 7 months. This is the latest finding from the METR Research Institute on the growth rate of AI capabilities. What is being discussed here is not exam scores nor computational speed, but the length of time AI can continuously work. This discovery comes from a systematic analysis of the past 6 years of AI development and may change the way we work in the future. Okay, let's talk about this important discovery by the METR Research Institute. I believe many people have this question. Why is it that AI, which performs excellently in various tests, often falls short in actual work? This study is the first to systematically answer this question. Current AI indeed demonstrates astonishing capabilities. In professional fields such as medical imaging diagnosis and legal document review, AI not only outperforms human experts, but also significantly reduces costs. But interestingly, the same AI often disappoints in practical work. They seem unable to independently complete an entire project and even struggle with basic remote assistant tasks. Let's imagine a scenario. Suppose you are a manager at a tech company with a very intelligent AI assistant. This AI can accurately answer 90% of the questions on a medical licensing exam, can complete complex mathematical calculations in seconds, and writes beautiful code. However, when you ask it to independently handle a complete project, such as refactor the code of this old system or design a new user interface, it always gives up halfway. This phenomenon has puzzled many researchers. Why is that? The Meta research team proposed a novel perspective. Instead of focusing on what AI can do, let's see how long it can persist. They designed a series of experiments to record the time it takes for human experts to complete various tasks. Starting with the most basic tasks, fixing a simple program bug takes about 3 to 4 minutes. Slightly more complex tasks, such as writing a new feature module, take around 30 minutes. More challenging tasks, like refactoring a complex code file, may take 2 hours. Designing and implementing a complete system usually takes a week. Through extensive testing, they discovered an interesting pattern that if a task only takes humans less than 4 minutes, current AI can almost always complete it. But when the task requires 15 to 30 minutes, the success rate of AI drops to half. More challenging is that if the task exceeds 4 hours, even the most advanced AI has a success rate of less than 10%. This situation is very much like a student who has trouble focusing. He may fully understand each point of knowledge, but just can't settle down to complete an entire exam paper. The problem with AI is not that it can't do the tasks, but that it can't maintain focus to string together multiple steps to completion. However, researchers have discovered an exciting trend. By analyzing data from the past 6 years, they found that AI's attention span is steadily increasing, doubling every 7 months. This pattern can be observed across various types of tasks. Taking software development as an example, we can clearly see this progress. At the beginning of 2023, AI could only reliably complete tasks like fixing a simple bug that took 2 to 3 minutes. By mid-2024, AI was already capable of handling tasks like writing a small feature module that took 8 to 10 minutes. By early 2025, AI will even be able to complete tasks like refactoring a moderately complex component within a 30-minute time frame. If this trend continues, by the end of 2027, AI may be able to independently complete projects that would take humans a week, such as designing and implementing a complete subsystem. How reliable is this prediction? The research team conducted comprehensive validation. First, cross-domain validation. They tested in different fields such as software development tasks, mathematical reasoning problems, and document writing tasks, and found that the rule of doubling every 7 months generally holds. Second, multi-dataset validation. In addition to observing the phenomenon of doubling every 7 months on the main test set, on the independent SWE bench dataset, the growth rate was even faster, doubling in about 3 months. Finally, error tolerance testing. The study found that even with a tenfold error in measurement, the predicted time would differ by at most 2 years. Interestingly, when the research team only looked at the latest data from 2024-2025, they found that progress might be faster than previously thought. According to the latest trends, AI's ability to handle monthly projects might arrive 2.5 years earlier than originally predicted. This study has revealed several key findings for us. Firstly, the bottleneck of AI capabilities lies mainly in the duration of tasks rather than individual skills. Secondly, the most advanced AI can stably complete tasks within 4 minutes, but often fails in tasks lasting more than 4 hours. Third, the time it takes for AI to process tasks doubles every 7 months, a trend that has remained stable over the past 6 years. Fourth, if the trend continues, by the end of 2027, AI may be able to complete projects that require a week of human effort. Finally, the latest data shows that the pace of this progress may be accelerating, with the ability to handle monthly projects expected to be achieved 2.5 years earlier. These findings bring us important insights. If this trend continues, AI may be able to independently complete monthly projects by 2030. What does this mean? It could bring unprecedented productivity improvements, but it also presents challenges that require serious consideration. How do we ensure that these powerful AI tools are used correctly? How can we redesign workflows to maximize the value of AI? Just as Moore's Law transformed the computer industry, this AI task length Moore's Law could fundamentally change the way we work. It is important that we prepare for a rainy day, think, and prepare in advance to better grasp this upcoming major transformation. Thank you all for watching, and we'll see you next time.